Civilizations rarely notice the moment their climate begins to turn. A harvest weakens, a river shifts, and one generation quietly learns to live with less. Centuries later, the pattern seems almost deliberate. Some climate records hint at a roughly 1,500-year rhythm, yet no global clock has been proven, and no civilization falls for one reason alone. So does climate truly reset civilization every 1,500 years? And did the last cycle begin 1,200 years ago? A climate shift announces itself with a morning. It arrives through differences easy to excuse. A winter begins later. A river rises less. The first rain comes after the seeds have waited in dry soil. One family remembers that the grass used to remain green longer, while another says old stories made the past sound kinder than it was. Nothing seems large enough to name. Nothing seems permanent enough to fear. Yet the change continues, season after season, until what was once unusual becomes ordinary. Those who notice it grow old. Their children inherit a landscape. Their grandchildren are born into conditions that would have seemed strange to those who came before, but to them, it is the world. This is one reason climate rhythms are difficult for human beings to perceive. A person can remember decades. A family can preserve stories for several generations. But a change unfolding over centuries moves beyond the limits of a single life. It does not pass before one pair of eyes. It is divided among countless bodies, each experiencing a fragment. For the earliest humans, long before cities and written calendars, survival depended on noticing patterns useful within a lifetime. The return of animals, the ripening of plants, the movement of water, the cold of an approaching season. These observations helped people decide when to move, where to gather, and which places could support a group. But a slow movement in climate could remain hidden inside shorter cycles. A valley might become drier over generations, not because every year was bad, but because good years became less frequent. A coastline might change as sea levels shifted, yet no one alive would witness the distance traveled by water. Human memory was shaped to guide life through seasons and generations, not to hold a continuous record across 15 centuries. This does not mean ancient people were unaware of environmental change. Archaeological evidence shows that communities changed where they lived, what they ate, and how they moved as conditions altered. But the evidence does not tell us how they understood those changes. We can see abandoned camps, different tools, food remains, and shifting settlement patterns. We cannot safely place modern explanations inside ancient minds. What matters is that climate entered human history through ordinary needs. A colder period changed the length of the growing season. A drier period changed the reliability of springs and rivers. A change in vegetation altered where animals could feed. These effects reached the body before they reached history books. They appeared as longer walks, smaller meals, heavier labor, and uncertain choices about when to stay or leave. Later, when humans built villages and depended on fields, herds, and stored grain, slow changes became harder to escape. A mobile group could sometimes move away from a failing landscape. A farming settlement had houses, graves, fields, and social ties fixed to one place. Its people could adapt, but adaptation required more than movement. It required new crops, agreements, routes, storage, or forms of cooperation. If those responses failed, the damage could appear sudden, even when pressure had been building for generations. From a distance, historians may see a date when a city was abandoned or a dynasty ended. The people living through it may have experienced no single ending. They may have known only that each year asked more of them than the year before. This is the first difficulty hidden inside the idea of a climate reset. The clock, if there is one, does not tick at the speed of human attention. It moves beneath memory, beneath custom, and beneath stories about how the world has always been. By the time a society recognizes that the familiar climate is no longer returning, the change may already belong to several generations. The question is whether human beings can recognize a transformation that unfolds too slowly for any one lifetime to see whole. When people hear that climate may reset civilization, the image is often too clean. It suggests that one world ends, the ground is emptied, and another world begins in its place. Real history is rarely so simple. A city can lose half its population and still remain inhabited. A kingdom can disappear while its farmers continue working the same fields. A language can survive after the palace that once used it has fallen into ruin. Even when drought, cold, flood, or shifting seasons place severe pressure on a society, human life does not usually return to zero. It bends, contracts, moves, divides, and reorganizes. The word reset can therefore hide several different processes. It may describe the collapse of a political system, the weakening of trade routes, the abandonment of large settlements, or the movement of people towards smaller and safer places. It may also describe a change in who holds power, who controls stored food, or which region becomes the new center of population. These are serious transformations, but they are not the erasure of human continuity. The earliest human communities already lived through this distinction. Long before formal states, groups could leave one valley and settle in another without losing every skill, tool, or relationship they carried. Knowledge traveled inside memory, practice, and habit. A community might lose access to familiar animals or plants, yet preserve methods of making fire, shaping stone, caring for children, and finding water. Later societies carried far more material weight. Fields, walls, canals, roads, temples, and burial places tied people to landscapes that could become less reliable. When those systems weakened, the visible center of life might fail first. Archaeologists can find empty houses, broken storage rooms, unfinished buildings, and declining imports. These remains make collapse easier to see than continuity. The people who moved away may leave fewer traces than the monuments they abandoned. This creates an illusion that everyone vanished when, in many cases, populations were dispersed rather than destroyed. A so-called reset may therefore be most dramatic from the viewpoint of states and cities. For families, it may appear as migration, a new crop, a different marriage network, or the loss of access to distant markets. For the body, it may mean less food, longer travel, harder labor, or greater dependence on relatives. For political leaders, it may mean that taxes cannot be collected, armies cannot be supplied, and authority no longer reaches the edges of a territory. Climate can contribute to all of these pressures, but it does not decide the outcome alone. Two societies facing similar rainfall changes may respond differently because one has grain reserves, flexible trade, and shared systems of water management, while another is divided by conflict or inequality. Calling both outcomes a reset can blur the difference between environmental stress and social failure. It can also make climate appear more powerful and human choices less important than they were. The title asks whether civilization is reset every 15 centuries. But before any rhythm can be examined, the thing being reset must be defined. Is it a capital city, a ruling dynasty, a regional economy, or the daily life of ordinary people? If a government disappears but communities remain, has civilization ended? If a population moves and carries its knowledge elsewhere, has the old world been erased, or has it changed its shape? These questions matter because the past is filled with endings that were also continuations. A date may mark the final inscription of a king, but not the final meal cooked in that language. A ruined city may mark the end of concentrated power, but not the end of the descendants who once lived there. The climate may alter the conditions of survival, yet the meaning of a reset depends on what human beings lose, what they preserve, and what they rebuild across landscapes, generations, and forms of life history rarely records clearly. A pattern becomes powerful when it gives confusion a shape, and few shapes are more comforting than a cycle, because a cycle suggests that what happened before may happen again, that disorder may contain a hidden schedule, and that history may be less uncertain than it appears. Yet, the desire for order can become strongest precisely where the evidence is incomplete, especially when climate records stretch across thousands of years and arrive as fragments from ice, mud, stone, pollen, and the floor of the sea, each fragment preserving a different signal, each one blurred by time, and each one requiring interpretation before it can be placed beside the others. So when researchers notice events separated by intervals that seem similar, the human mind is naturally drawn toward repetition. But similarity is not the same as regularity, and an average distance between events is not the same as a clock that strikes at fixed moments. This distinction matters because the number 1500 years carries an unusual psychological weight. It is long enough to feel beyond ordinary history, yet short enough to divide the rise and decline of familiar societies into a sequence that appears meaningful. Once the number is known, the past can begin to look arranged around it. A cold interval here, a drought there, a migration, a political crisis, an abandoned settlement, and a later recovery. But the farther the search expands, the easier it becomes to select events that fit while overlooking regions that changed at another time or did not show the same disturbance at all. Early humans did not live inside numbered cycles. They lived inside local conditions, following water, plants, animals, coastlines, and seasonal opportunities. Their survival was shaped by variation, but the archaeological record does not show humanity rising and falling together at one shared interval. Instead, it shows different populations responding to different environments, sometimes moving, sometimes remaining, sometimes exchanging tools or practices, and sometimes becoming separated for long periods. This unevenness remained after farming, cities, and states appeared, because a shift in North Atlantic circulation could influence nearby weather strongly, while reaching distant regions through weaker, delayed, or entirely different pathways. A dry phase in one landscape could coincide with favorable rain elsewhere, and a period remembered as crisis by one society could be a time of expansion for another. The idea of a perfect global rhythm smooths away these differences. Turning many histories into one story, it also risks confusing coincidence with cause, since a society can weaken during climatic stress while also facing warfare, disease, trade disruption, political division, soil damage, or unequal access to food. Climate may intensify such pressures without acting as their single origin, and a date close to a proposed cycle cannot prove that the cycle produced the event. The deeper attraction of the pattern may come from a human need older than civilization itself, the need to recognize returning conditions before they become dangerous. A mind that notices repetition can prepare for winter, remember where animals gather, or anticipate when a plant will bear fruit. This ability helped human beings survive, but the same ability can detect order in events that are only partly related, especially across spans no person can experience directly. So the 1500-year idea must be approached neither as nonsense nor as prophecy, but as a question formed from real evidence and limited by real uncertainty. The records may contain recurring tendencies, interacting ocean patterns, changes in solar activity, ice behavior, or internal climate variability. Yet, these influences need not combine in the same way every time, and they need not reset civilization on command. Before the origin of the number can be understood, one quiet fact must remain in view. Nature can repeat without becoming punctual, and human history can echo without obeying a schedule that any generation could read as a certain warning of what comes next. Far below the restless surface of the ocean, the past settles slowly. Dust carried by wind falls through the water. Tiny shells sink after the organisms that made them die. Rivers deliver grains eroded from distant land. In colder times, drifting ice can carry stones far from the places where they formed, then release them as the ice melts. Layer by layer, this material gathers on the seafloor, creating an archive no human community intended to preserve. The archive is not written in words, and it does not remember every storm or every difficult harvest. It records conditions indirectly through changes in sediment, chemistry, and the remains of life. To read it, researchers recover long cylinders of mud from beneath the ocean. The material near the top is generally younger, while deeper layers are usually older, although currents, burrowing animals, erosion, and disturbed deposits can complicate that simple order. Each core is therefore both a record and a puzzle. Its colors may change. Coarse grains may appear where fine mud once dominated. Certain microscopic shells may become common, then rare. Their chemical composition may reflect properties of the water in which they formed. None of these signs speaks alone. They must be compared with one another, dated carefully, and interpreted within the geography of the place where the sediment accumulated. This caution becomes especially important in the North Atlantic, where much of the proposed long climate rhythm was first discussed. During colder periods of the distant past, icebergs crossed parts of this ocean carrying fragments of rock and soil. When they melted, the debris descended into deep water. Finding an unusual concentration of such grains can indicate that more drifting ice reached that region, but it does not by itself reveal exactly why the ice moved, how large the event was everywhere, or what people experienced on distant continents. The ocean floor remembers transport and deposition more directly than it remembers civilization. Human history must be connected to that record through additional evidence. A layer of coarse debris cannot tell us that a kingdom failed. A change in microscopic marine life cannot tell us that a family left its home. Archaeological remains, written records where they exist, pollen, lake deposits, cave formations, and other climate evidence must be placed beside the marine record before a historical argument becomes strong. Even then, the connection may remain uncertain because dates carry ranges rather than perfect points. This is very different from the memory available to the first humans. They watched coastlines, tides, animals, clouds, and seasonal water, but they could not lower instruments through thousands of meters of ocean or compare deposits separated by entire seas. Their knowledge was immediate, local, and carried through living communities. Modern research extends that human attention beyond a lifetime by allowing mud to become a form of memory. By joining many cores, scientists can compare broad movements in ocean conditions. Yet every comparison depends carefully on assumptions about age, sedimentation, preservation, and the meaning of each measured signal. Yet the extension does not remove uncertainty. A core represents one location. Sediment may accumulate quickly in one place and slowly in another. A thin layer can contain many years, while a thicker layer elsewhere may preserve a shorter interval. Two cores taken from different regions may appear to show related changes, but proving that those changes happened at the same time requires careful dating. This is why the search for a 15th century rhythm begins not with a visible clock, but with scattered traces that must be aligned across space and time. The ocean offers evidence of repeated change, sometimes clear and sometimes faint, but it does not label any event as a reset. It preserves physical consequences, leaving later generations to ask whether those consequences belong to a recurring climate process, a regional disturbance, or several different forces that only seem orderly when viewed from far away. The ocean is not the only place where climate leaves a memory, because ice, trees, caves, and lakes each preserve a different trace of conditions that no human witness could observe across thousands of years. And each archive speaks in its own language. Ice can trap bubbles of air and hold particles carried by wind. Tree rings can reflect how strongly a tree grew during a season. Mineral layers inside caves can change as rainfall and groundwater shift. And lake mud can collect pollen, charcoal, dust, and the remains of organisms. Together, these records allow researchers to compare temperature, moisture, vegetation, fire, and atmospheric change. But none of them offers a complete account of the world. An ice core from Greenland may preserve changes in that region with detail, while saying less about rainfall in Africa or monsoon strength in Asia. A tree may record years of stress, yet its growth can be influenced by temperature, water, sunlight, age, disease, and competition with plants. Cave deposits can grow slowly over long spans, but the meaning of their chemistry depends on the path water followed through soil and rock. Lake sediments can preserve local changes in vegetation, although wind, erosion, floods, and human activity may alter what reaches the lake. The strength of paleoclimate research comes not from trusting one archive alone, but from asking whether several independent records point toward a similar change. If tree rings suggest prolonged dryness, lake levels fall, pollen shifts toward plants suited to arid conditions, and archaeological settlements become smaller or move toward reliable water, the combined picture becomes stronger, though it still does not prove that climate alone caused every human response. This comparison matters because the first humans lived inside environments that changed long before written history began. Their bodies depended on water, edible plants, animals, shelter, and seasonal movement. But the evidence left behind cannot tell us exactly what any group believed about a long drought or colder generation. It can only show changes in where people lived, what resources they used, and how their material lives were organized. The natural archives help place those traces within a wider environmental setting, yet they must never be used to invent thoughts, fears, or decisions that archaeology cannot support. A narrow tree ring cannot tell us why a family moved, and a layer of cave mineral cannot reveal what a community expected from the coming year. They provide conditions, not intentions. Another difficulty is that these archives measure time differently. Annual tree rings may offer a clear sequence when the wood is preserved and correctly matched. Ice layers can sometimes be counted through long stretches, while lake mud and cave deposits may require chemical dating with wider ranges of uncertainty. A change that appears sudden in one record may be spread across decades in another, because material accumulated more slowly. Local disturbances can also interrupt the sequence. Fire can remove trees, flowing water can erode cave deposits, and animals can mix lake sediment. Therefore, researchers do not simply place four records side by side and declare that a global event occurred at one exact moment. They examine how each archive formed, how securely it is dated, and whether the same signal appears across enough places to justify a broader interpretation. This is especially important when searching for a rhythm near 1500 years, because a repeated spacing can seem convincing if uncertain dates are treated as precise, yet appear less regular when the full dating ranges are considered. The Earth does preserve echoes of past climate, but those echoes arrive through different materials at different speeds, and from landscapes that did not experience change in identical ways. The record becomes meaningful only when its differences are respected, because the history of climate is not stored in one perfect book. It is scattered across ice, wood, stone, mud, and the altered paths of human life. Ancient climate records do not line up like pages printed from the same calendar, because every archive measures time through a different physical process. A tree ring may represent one growing season, an ice layer may preserve a year in one interval and become compressed in another. A cave deposit may grow for centuries and then pause, while lake and ocean sediments may accumulate unevenly over time. Two records can therefore describe the same climatic movement without assigning it to the same year, and they can appear to match even when the changes were separated by decades, because a pattern that looks precise on a simplified timeline can become less regular once the full uncertainty is restored. Dating methods are powerful, but they are not perfect clocks. Radiocarbon measurements require calibration because atmospheric carbon has varied through time. Layers can be counted incorrectly where annual signals are faint, and material in sediment may be older than the layer in which it was deposited. Researchers therefore compare indicators, test alternative age models, and report ranges, rather than pretending that every event began on one exact morning. This caution matters when climate history is connected to human history, since an archaeological settlement, a drought record, and a marine sediment change may each carry different dating limits. If their ranges overlap, the connection may be plausible, but overlap alone does not prove that one caused the other. The earliest human populations moved through landscapes where rainfall, temperature, vegetation, and coastlines changed over long periods. Yet the surviving record rarely allows a modern observer to reconstruct one complete chain of cause and response. A campsite may have been abandoned during a dry interval, But people may also have moved because animals shifted, resources declined, conflict increased, or another place became more attractive. The environmental record provides context, not a complete explanation. And the same principle applies after villages, farming, and states appeared, because historical change usually emerges from several pressures acting together. Another problem is distance. Climate does not move across the planet as one uniform wave. Changes in ocean circulation can strongly affect the North Atlantic while producing weaker, delayed, or opposite effects elsewhere. Monsoon systems respond to combinations of land temperature, ocean conditions, seasonal winds, and atmospheric circulation. Tropical rainfall may shift, mountain snow may change independently of coastal temperature, and one region may become drier while another becomes wetter. Even when both changes belong to a wider reorganization, this is why a signal discovered in Greenland ice or North Atlantic sediment cannot automatically be treated as a global event. It may reveal an important regional process, and it may connect to distant places, but those links must be demonstrated rather than assumed. The challenge becomes greater when the proposed interval is close to 1500 years, because dating uncertainty can make separate events appear evenly spaced. And because researchers may compare events that differed in duration, intensity, geography, and cause, one cold episode may last generations, another may be brief, and a third may be visible only in one archive. Placing them on a single line can create the impression of repetition while hiding those differences. Early farming communities experienced climate through local fields, water sources, grazing land, and seasonal labor, not through a global average. So the meaning of any shift depended on where people lived, what foods they relied upon, how much storage they had, and whether movement or exchange remained possible. A date that marks stress in one valley may mark little change in another, and a century that looks severe in marine data may contain many ordinary years in distant communities. The Earth preserves climate history, but it preserves many local histories within it. And the closer we look, the more a synchronized rhythm gives way to an uneven landscape of changes that must be connected carefully before any claim of a civilizational reset can be trusted. Long before cities, fields, or written calendars, the climate of the northern world could change with a speed that would have been difficult for any human community to understand. Greenland ice cores preserve some of the clearest evidence. In layers formed during the last glacial period, researchers have identified repeated episodes in which temperatures over Greenland rose sharply, remained relatively mild for a time, and then returned more gradually toward colder conditions. These episodes are known as Dansgaard-Oeschger events. They did not occur with perfect regularity, and they were not simple global switches. Yet they reveal that the climate system can reorganize far more abruptly than the slow movement of centuries might suggest. In some cases, much of the warming recorded in Greenland appears to have unfolded within a human lifetime, perhaps even faster than that. The exact timing and magnitude vary by event and by method of reconstruction, so the record should not be turned into a single dramatic number. What matters is the contrast. A generation could be born into severe cold and die in conditions that were noticeably different. For early human populations living across Europe and Western Asia, such shifts would have altered vegetation, animal ranges, snow cover, water availability, and the length of useful seasons. Archaeology cannot tell us exactly what people thought when familiar landscapes changed. It can only show that human groups repeatedly adjusted where they lived, what they hunted, and how they moved through uncertain environments. The ice records give scale to those changes. Without supplying private thoughts or simple explanations, scientists have proposed several connected mechanisms for the abrupt Greenland warmings. Many involve changes in Atlantic Ocean circulation, sea ice, and the movement of heat between the ocean and atmosphere. When ocean circulation weakens or strengthens, heat can be redistributed across the North Atlantic region, affecting winds, ice cover, and temperatures. Yet no single explanation captures every event perfectly. and the causes may not have been identical each time. Some episodes may have been influenced by freshwater entering the ocean, while others may have emerged from internal instability within the coupled ocean and ice system. The evidence therefore points toward recurring behavior without proving the existence of one precise clock. This distinction is essential because the proposed 15th century rhythm is often linked to these abrupt glacial changes. Certain intervals between events appear close to that value, especially when several shorter intervals are grouped together, but the spacing is uneven. Some events occurred much closer together. Others were separated by longer periods. Statistical studies have reached different conclusions about whether the sequence reflects a true external pacing, a tendency within the climate system, or patterns that arise from irregular variability. The first humans did not experience an average interval. They experienced particular winters, migrations, shortages, and opportunities within local landscapes. A climate signal visible in Greenland could influence nearby regions strongly, while reaching distant populations in weaker or different forms. Even across Europe, conditions were not identical from one place to another. Mountains, coastlines, forests, open plains, and ice margins created separate worlds of risk. This is why the Dansgaard-Oeschger record is so important and so easy to misuse. It proves that large and rapid climate shifts occurred during the Ice Age. It does not prove that civilization is reset every 1500 years. Because civilization did not yet exist in the later urban sense, the events were not perfectly periodic, and their strongest expression was regional rather than uniform across the planet. Still, these ancient warmings reveal a deeper possibility behind the title. The climate system can hold tension for long periods, then change quickly enough that one generation inherits a world unlike the one known by its grandparents. The unanswered question is whether the faint rhythm seen in these glacial layers continued after the great ice sheets retreated, when human beings began to build permanent settlements and place more of their survival inside fixed landscapes. After the great ice sheets began to retreat, the climate of the North Atlantic became calmer than it had been during the deepest cold of the glacial age. But calmer did not mean still, because ocean circulation, sea ice, winds, and the movement of freshwater continued to change, including grains with distinctive mineral and color characteristics that could be linked to northern lands. These increases were not enormous copies of the great glacial disruptions, yet they suggested that colder surface waters and floating ice had reached farther into areas of the North Atlantic at intervals during the Holocene, the long period in which farming, villages, and cities developed. The recurring concentrations became associated with the name of the geologist Gerard Bond, whose team compared several marine indicators and proposed that a rhythm near 1500 years could be present across both glacial and later records. The number was never a perfect distance between every event, and the deposits themselves did not form a row of evenly spaced marks. Instead, the proposed pattern emerged from averages, groupings, and comparisons among signals that varied in strength and timing. This is where the idea behind the title gained much of its scientific shape, not from a list of civilizations that collapsed on schedule, but from physical evidence that North Atlantic conditions may have shifted repeatedly on a millennial scale. Ice-rafted debris is valuable because ordinary ocean currents cannot easily carry every coarse grain found far from land. An iceberg can freeze rock fragments into its body, travel with winds and currents, and release them when it melts. But the presence of that debris does not identify one cause. Because the amount reaching a core depends on iceberg production, the paths taken by ice, the location of melting, changing currents, and the source of the sediment, a peak can therefore reflect several processes acting together rather than one global fall in temperature. And even where a colder North Atlantic phase is well supported, its effects on human communities must be examined region by region. Early farmers near one coast may have experienced shorter growing seasons or altered rainfall, while people around another sea or within another monsoon system could have faced a different change at a different time. The first settled societies were no longer as free to follow food across vast distances as many earlier mobile groups had been. Yet they were not passive. They changed crops, storage practices, exchange networks, and settlement locations, leaving archaeological patterns that sometimes overlap with climatic shifts but rarely prove a single cause. The Bond events are therefore best understood as a proposed sequence of North Atlantic cold episodes, not as confirmed moments when civilization was erased. Their numbering can also create a misleading sense of certainty, because later researchers have debated which events are distinct, how widely they can be traced, and whether the apparent spacing is statistically stronger than patterns produced by irregular climate variability. Some suggested events coincide with recognizable regional disturbances, while others are weak or difficult to match beyond the marine cores in which they were defined. The record remains important because it shows that the relatively stable Holocene contained meaningful fluctuations, but stability itself is a matter of scale. Compared with the Ice Age, the changes were often smaller, while compared with the needs of a farming community dependent on reliable rain, even a modest shift sustained across generations could matter deeply. What the ocean floor offers is not a calendar of human endings, but a sequence of environmental signals whose resemblance invited the idea of a hidden rhythm. And the central problem is whether that rhythm belongs to the climate system itself or to the way scattered evidence has been arranged by minds searching for repetition. A climate rhythm can be real without behaving like a clock, and this is the most careful way to approach the proposed interval of roughly 1,500 years because the evidence allows several explanations that overlap rather than one conclusion that removes all doubt. The first possibility is that some feature of the climate system tends to return on a broad millennial timescale, perhaps through changes in ocean circulation, sea ice, freshwater, winds, or the movement of heat between regions. Such a tendency would not need to strike at identical intervals, just as seasons repeat without every winter beginning on the same day or bringing the same cold. The second possibility is that several shorter or irregular influences sometimes combine to create a larger pattern. Solar variations, internal ocean changes, ice behavior, and atmospheric circulation may reinforce one another during some periods and cancel one another during others, producing clusters of events that look more regular when viewed across many thousands of years. The third possibility is that the apparent rhythm may be created by the way incomplete records are dated, selected, and compared, because random or uneven events can produce a strong statistical peak when the sequence is short, uncertain, or divided into groups. Researchers have tested these possibilities with different methods and have not reached one final agreement. Some studies find support for repeated millennial variability in the North Atlantic, while others show that noise-driven climate shifts can imitate a spacing near 1,470 years. This disagreement is not a failure of science. It is the normal result of asking a precise question of records that were never designed to answer it. The mud beneath the ocean does not preserve every year equally. Ice layers become compressed, age estimates widen deeper in time, and the choice of which event counts as distinct can influence the pattern that appears. A rhythm may therefore be physically meaningful without being exact, or statistically impressive without representing an external timer, and both possibilities must remain open. A disturbance may fade when oceans, ice, and winds absorb it, while a similar disturbance at another time may cross a threshold and spread through connected systems, which means recurrence does not require repetition. The background state matters, the size of ice sheets matters, ocean salt balance matters, and the same forcing can produce an entirely different response in a different climatic world. This distinction becomes even more important when the proposed climate spacing is connected to human civilization. Early human populations experienced changes through local water, food, vegetation, animal movement, and shelter, not through a numbered global cycle. Later farmers and urban societies were more fixed to fields, canals, roads, and storage systems, yet they still faced regional climates rather than one worldwide signal. Even if the North Atlantic repeatedly shifted on a similar timescale, no evidence shows that all societies were reset together. One region could suffer colder seasons, another could receive altered rainfall, and another might experience little measurable change, while political stability, trade, inequality, conflict, crop diversity, and access to water shaped whether environmental pressure became crisis, migration, adaptation, or gradual transformation. The attraction of a single cycle is that it promises a clean explanation for a complicated past, but the evidence points toward a climate system with memory, thresholds, feedbacks, and recurring behavior, rather than a hidden machine counting down identical centuries. The proposed 1500-year rhythm remains useful because it directs attention to changes too slow for written memory and too long for ordinary observation. Yet its value lies in the question it raises, not in a prophecy it supplies. Nature may revisit similar conditions without repeating the same event, and human societies may encounter familiar pressures without reaching the same fate. So the number should be carried forward as a hypothesis to examine, never as a calendar that can announce when civilization must begin again. Before fields, walls, and permanent houses tied survival to one landscape, mobility gave many human groups a way to respond when food, water, animals, or seasons changed, yet movement was never effortless and should not be imagined as an easy escape from hardship. Carrying children, tools, fuel, food, and knowledge across unfamiliar ground demanded energy, planning, cooperation, and access to places where other people might already live. Still, compared with later farming communities, mobile foragers often had greater freedom to shift camps, alter seasonal routes, or spend more time in landscapes that remained productive. Archaeological evidence from many regions shows that hunter-gatherer mobility varied widely. Some groups moved residential camps often, others returned repeatedly to favored places, and many combined stable base camps with shorter journeys for hunting, gathering, fishing, or collecting stone, wood, and water. This variety matters because there was no single prehistoric lifestyle and no universal response to climate. A colder interval might reduce one plant food while opening another hunting opportunity. A dry phase might make a spring unreliable while concentrating animals near remaining water. And a changing coastline could remove familiar ground while creating new wetlands or marine resources elsewhere. People could respond by adjusting when they traveled, how far they ranged, which foods they used, and whom they exchanged materials with, but the surviving evidence usually records the result more clearly than the decision. Stone tools appear far from their geological sources. Camps are occupied in different seasons, animal bones change in frequency, and settlements shift across valleys, coasts, or elevations. These traces suggest flexible behavior without allowing us to claim exactly what any individual understood or intended. Mobility also depended on memory held by the group. Routes had to connect water, shelter, raw materials, and places where food returned predictably. Such knowledge was not separate from human origins. It was one of the practical forms through which early humans survived environments that changed across generations. Bodies alone could not outrun every drought or cold period, but shared knowledge could widen the landscape available to them. A remembered spring, a distant patch of edible plants, or a relationship with another group could become as important as physical strength. This did not guarantee safety, because moving into a new area could bring hunger, injury, conflict, or failure to locate resources. And some environmental changes were too broad or rapid to avoid through relocation. Populations could decline, become isolated, or disappear from particular regions. Yet, the larger archaeological record shows repeated human returns, expansions, and adjustments, rather than one synchronized collapse. That uneven history is important for the claim that climate resets civilization. Before civilization existed, climatic pressure did not place all humanity on one clock. It altered separate landscapes, and human groups responded through different combinations of movement, diet, technology, cooperation, and population change. Mobility, reduced dependence on a single field or river, but it also limited the amount of stored material and heavy infrastructure a group could carry. Resilience came partly from having less fixed investment in one place. Later agriculture would reverse that balance, producing greater food surpluses while binding more lives to particular soils, seasons, and water systems. The earliest protection against environmental uncertainty was therefore not control over climate, but the ability to change location, schedule, and subsistence before familiar conditions failed completely. And this old flexibility reveals why climate change alone cannot be treated as an automatic reset, because even under severe pressure, human survival depended on the routes, relationships, knowledge, and choices available between one threatened place and the next, where movement remained possible. Danger could be spread across space rather than concentrated in one settlement, but where mountains, deserts, ice, rival territories, or exhausted resources closed those paths, mobility lost much of its protective value, reminding us that adaptation was always conditional, local, and limited by the social as well as the physical landscape around each group. Climate did not reach early human communities as an abstract change in temperature. It reached them through the amount of food that could be found, the distance required to obtain it, the reliability of water, and the energy needed to remain alive. When rainfall shifted, plants could flower later, fruit less often, or disappear from ground. Animals could follow new grazing routes, fish could become harder to reach, and waterholes could shrink before the dry season ended. Every one of these changes placed pressure on the human body, not as a dramatic event shared equally by everyone, but as a gradual alteration in effort. A longer walk meant more energy spent before food was gathered. A smaller return from hunting meant less to divide among children and adults. A colder season increased the need for shelter, fire, clothing, and calories, while a hotter and drier season could make travel more exhausting and reduce the time that food remained usable. The archaeological record can sometimes reveal these pressures through changes in animal bones, plant remains, settlement location, skeletal growth, and the frequency of signs of nutritional stress. Yet such evidence must be interpreted carefully because a mark on bone may have several causes, a small body may reflect many influences, and one burial cannot represent a population. What can be said with greater confidence is that climate altered the conditions under which food became available, and those conditions shaped how many people a landscape could support. Long before farming, human survival depended on flexible diets, shared labor, memory, and the ability to move between resources. These capacities belong to the deep beginnings of our species, but they did not remove biological limits. A group could know many foods and still face shortage when several resources failed together. It could remember distant water and still lack the strength to reach it. It could divide food carefully and still lose members when scarcity lasted too long. Climate pressure also changed the balance between generations. Children required protection and regular nourishment. Older people could preserve knowledge of places and seasons, and healthy adults often carried much of the labor involved in travel, hunting, gathering, tool-making, and care. When food became less reliable, the loss of even a few capable members could reduce what the whole group was able to do. This does not mean that every difficult period caused collapse, because cooperation, exchange, mobility, and varied food sources could soften the effects. But it shows why environmental change could become a population problem without ever appearing as one sudden disaster. Over time, fewer births, higher mortality, delayed recovery, or movement into safer regions could alter the size and distribution of communities. These changes might later appear in archaeology as empty sites, reduced occupation, or new patterns of contact, yet the people living through them would have experienced hunger, fatigue, distance, and uncertainty, rather than a named climatic cycle. The same connection between environment and body continued after farming began. Although it took a new form, settled communities could store grain, keep animals, and produce more food from a smaller area, but dependence on a few crops made repeated harvest failure more dangerous. When rain arrived at the wrong time or cold shortened the growing season, the body again became the final place where climate was measured through workload, diet, recovery, childhood growth, and the ability of a population to care for those who could not produce food themselves. The origin of human resilience was never freedom from nature. It was the social capacity to share risk, remember alternatives, and adjust before shortage became irreversible. Climate did not reset humanity by touching every society at once. It changed the biological margin within which people could move, cooperate, reproduce, and survive. And the narrower that margin became, the more local environmental change could reshape generations without leaving a single moment that history could call the beginning. When a human group left a valley, coast, forest, or plain, the place might disappear from its daily life, but not everything connected to that place was lost. People could carry stone tools, ornaments, fire-making materials, food, and useful objects. Yet the most important things often had no weight at all. Knowledge of plants, methods of preparing hides, ways of shaping wood, memories of water, seasonal routes, kinship ties, and habits of cooperation could move with them. Archaeology rarely preserves these invisible possessions directly, but it can reveal their continuation through familiar techniques appearing in new locations, raw materials traveling across long distances, repeated styles of toolmaking, and settlements linked by exchange. These traces suggest that movement did not always break cultural life. It could also extend it across a wider landscape. This matters when climate changed, because leaving a threatened place was not the same as beginning again without memory. A group reaching a new region still carried practices learned over many generations. Some remained useful, others had to be adjusted, and new knowledge could be gained through contact with people already living nearby. The earliest human resilience was therefore partly social, not simply physical. Survival depended on bodies capable of walking and working, but also on relationships that made information, food, shelter, and access to territory available. A person alone could know a route, while a community could preserve many routes, compare seasons, and remember alternatives after one source failed. Such knowledge reduced uncertainty, though it never removed danger. Migration could separate relatives, expose people to unfamiliar diseases or resources, increase conflict, and demand more energy than weakened bodies could provide. Some groups probably disappeared from particular landscapes, while others joined neighboring populations or divided into smaller communities. The archaeological record often shows the abandoned place more clearly than the people who left it. A hearth ends, tools become scarce, and occupation layers stop, yet the descendants of those inhabitants may have continued elsewhere beyond the area being excavated. This is one reason a climatic disruption can look like a complete break when viewed from a single site. The visible settlement ends, but skills, genes, stories, and social connections may continue across another region long before written archives. Continuity was held in repeated action. A child learned by watching food gathered, stone struck, fire protected, and paths followed. No written instruction was needed for knowledge to survive. Although every generation could alter what it received, some practices faded when environments changed, others became more important, and still others were combined with unfamiliar methods. This gradual transformation connects directly to the origins of human adaptability. Our ancestors did not preserve life by remaining unchanged. They preserved it by carrying enough of the past to function in a different present. Later civilizations would do something similar on a larger scale. When cities declined, people often moved with crops, crafts, languages, beliefs, and family networks, meaning that political collapse did not erase all cultural inheritance. Climate could remove the conditions that supported one settlement pattern, but it could not automatically empty human memory. A true reset to zero would require the disappearance of people, knowledge, and connection together. While most environmental transitions preserved at least some of these across space and generations, what survived was not always the original home, the old authority, or the familiar route. Sometimes it was the quieter ability to rebuild ordinary life elsewhere, and that continuity makes the idea of civilization being reset by a repeating climate clock far less complete than the ruins alone might suggest. The deeper pattern is therefore not repeated erasure, but repeated translation. As communities carried old solutions into new environments, discovered where those solutions failed, and formed new combinations suited to different water, animals, plants, neighbors, and seasons, leaving history with discontinuous places but a more continuous human inheritance than any abandoned camp or ruined settlement can fully reveal. The first farmers did not simply discover a safer way to live, they entered a new agreement with place. Seeds had to be planted in particular soil at a particular time and protected until harvest. Animals had to be watched, fed, and kept near water. Houses, storage pits, tools, and paths accumulated around fields that could not be carried elsewhere. This gave settled communities advantages that mobile groups rarely possessed in the same form. Food could be produced in larger amounts, grain could be stored, and many people could live within a smaller area. Yet every gain created a new dependence. A field could fail, a herd could weaken, a canal could dry. A settlement that had spent generations building walls, graves, and social ties could not respond to environmental stress by moving as freely as earlier foragers sometimes had. The shift toward farming was gradual and uneven, and it did not occur everywhere for the same reason. Some communities combined cultivation with hunting, fishing, or gathering for long periods. Others moved seasonally even while tending crops. Archaeology shows many intermediate ways of living, so farming should not be treated as one sudden invention that transformed all humanity at once. Still, as more labor and memory became attached to fixed landscapes, climate gained a stronger hold over daily life. Rainfall no longer affected only where wild plants grew. It affected whether planted seeds survived. Temperature no longer shaped only the movement of animals. It shaped the length of the growing season and the time available for crops to mature. The origin of this vulnerability reaches back to the same human abilities that had once supported mobility: memory, cooperation, planning, and the sharing of knowledge. People learned which seeds produced useful plants, how soil behaved, when water arrived, and how food could be stored. These skills allowed communities to remain in one place, but they also encouraged larger investments in that place. A successful harvest supported more children, more houses, and more specialized work. Over time, the number of people needing the next harvest could grow. The settlement became stronger in ordinary years and more exposed when ordinary conditions failed to return. Moving was still possible, but it became more costly. A family leaving its fields might lose stored food, access to irrigation, claims to land, and the support of neighbors. Entire communities could not simply walk away from terraces, canals, orchards, or herds without abandoning years of labor. This attachment was not only material, burial grounds connected generations to the same soil. Shared rituals, boundaries, and agreements made the landscape part of social identity. Climate pressure therefore entered a web of obligations that had not existed in the same way for small mobile groups. A dry year could force people to choose between consuming seed grain and preserving it for the next planting. Repeated floods could destroy houses as well as crops. A colder interval could reduce yields while increasing the need for fuel and shelter. None of these events automatically destroyed a village, because storage, exchange, crop diversity, and cooperation could provide protection. But the room for movement had narrowed. The earliest humans survived partly by spreading risk across space. Farming communities increasingly spread risk across time, storing food from good seasons for difficult ones. When bad seasons lasted longer than reserves, debts, agreements, or patience could endure, environmental stress began to move through society. This was the deeper change created by settled agriculture. Climate no longer affected only the landscape people used. It affected a system of labor, expectation, population, and memory built around the belief that the same land would continue to support life. The question was no longer simply where people could go when conditions changed, but how much of a settled world they could preserve before leaving became less dangerous than staying, and whether the knowledge that created permanence could also create new forms of adaptation when familiar seasons no longer returned. Stored food changed the meaning of a good harvest, because grain gathered in one season could support life after the fields had turned bare, allowing a village to survive winter, feed children, care for injured people, and reserve seed for the next planting. And this ability to move food through time was one of the foundations of settled society. Yet the same surplus that protected people also allowed more lives, tasks, and expectations to gather around it. Houses became more permanent, populations grew, specialists could spend less time producing food, and leaders or institutions could claim a share of what farmers stored, so the harvest was no longer only a family matter. It became the energy that supported an entire social structure, including builders, craft workers, traders, ritual specialists, guards, and administrators. In favorable years, this arrangement could make a community stronger than a smaller mobile group because stored grain reduced the need to search constantly for food and made coordinated labor possible. Canals could be repaired, walls raised, roads maintained, and distant exchange supported, but each success increased the number of people depending on the next season. Surplus therefore created safety and fragility at the same time. It softened short shortages while building systems that required continued production. A single weak harvest might be absorbed by reserves. 2 difficult years might demand rationing, exchange, or the slaughter of animals, but repeated failure could reach beyond the amount stored and begin to alter relationships within the community. Families with larger reserves could endure longer. Households in debt could lose land or freedom. Authorities might collect grain even when local needs were growing, and trust could weaken if food was distributed unequally. Climate pressure then moved from soil into social order, not because drought or cold commanded people to fight, but because scarcity narrowed the choices available to everyone. The deep origin of this dependence lay in a human capacity that had once supported survival in mobile groups, cooperation, memory, and planning. Farming transformed those abilities into granaries, calendars, irrigation schedules, property claims, and obligations between generations. A storehouse represented confidence that food saved now would still be protected and shared later, and that confidence could be as important as the grain itself. If people believed reserves would be taken, spoiled, or withheld, the protective value of storage declined before the food physically disappeared. Surplus also encouraged settlement in places where ordinary rainfall was not enough without organized water management. Irrigation could make dry land productive, but canals required maintenance and agreements over timing and access. When rivers changed course or rainfall weakened, the danger was not merely less water, it was the possible failure of a network connecting fields, labor, authority, and distribution. This is why climate cannot be separated from institutions when examining civilizational change. Environmental stress affected what could be produced, while social arrangements determined who received protection, who carried the burden, and how long cooperation could continue. Many farming communities adapted through varied crops, smaller herds, wider trade, improved storage, or movement to less exposed land. And these responses often prevented a crisis from becoming collapse. But where population, inequality, or rigid obligations had grown faster than resilience, the same surplus that once created security could leave a society with more mouths, more promises, and fewer ways to retreat, revealing that abundance did not free civilization from climate. It made the relationship deeper, more organized, and more difficult to unwind. As generations passed, people could regard full storehouses and dependable harvests as normal, even though that normality rested on rainfall, soil, labor, transport, and political cooperation continuing together. When one support weakened, others could compensate for a time. When several weakened at once, reserves became a measure of how long the old arrangement could survive. The apparent strength of the settlement was therefore also a record of how difficult life had become without these supports working together. A failed harvest rarely ends at the edge of a field, because the first loss is measured in grain, but the next losses appear in labor, trust, debt, health, movement, and political authority. When rain arrives too late, when heat shortens the season, or when repeated storms damage crops, the immediate result may be smaller yields. Yet a farming community does not respond as one body. Households begin with different amounts of land, livestock, stored food, tools, and support from relatives. Some can absorb the shock, others must reduce meals, sell animals, borrow seed, or exchange future labor for food in the present. This uneven beginning matters, because climate pressure often widens differences that already exist. The household with a full storehouse can wait, while the household with little reserve must make decisions that weaken its position in the next season. Seed grain may be eaten, animals needed for work may be sold, tools may be lost to creditors, and children or older people may receive less food. None of these choices is irrational. Each is an attempt to survive the present, but together they can make recovery more difficult. The body becomes the first limit. Tired workers cultivate less land, undernourished people recover more slowly, and longer journeys for water or fuel consume energy that would otherwise support planting, repair, and care. The family becomes the second limit, because when every member is needed for labor, illness, injury, or absence carries greater cost, relatives may help for a time, but their own reserves may also be shrinking. The village becomes the third limit. Storage must be opened, canals repaired, grazing shared, and disputes settled. If cooperation remains strong, the burden can be spread, but if trust has already weakened, people may hide food, resist contributions, or leave before common resources are exhausted. The origin of this vulnerability lies in the same human capacities that made settled life possible: planning, memory, obligation, and cooperation. Fields and granaries turned these capacities into a network extending across seasons, yet a network protects only while enough of its links continue to function. Trade can bring food from another region, but only if roads remain open, partners have surplus, and communities can pay. Rulers can release reserves, but only if those reserves exist and distribution is accepted as fair. Communities may also change what they plant, divide herds, deepen wells, or organize seasonal movement. But each response requires time, knowledge, labor, and agreement. Resources that scarcity itself can steadily reduce. So resilience is never a permanent possession. It must be rebuilt through every difficult year. Taxes can support irrigation and defense, but during scarcity, they may also remove food from households already near their limit. Climate, therefore, does not command collapse. It narrows the space within which social choices can be made. A short shortage may strengthen cooperation, a longer one may expose inequality, and repeated failures may push people to migrate, abandon marginal fields, resist authority, or gather around new leaders who promise access to food and water. Archaeological evidence may later show smaller settlements, fewer imported goods, neglected public works, or changes in diet, but these are the final traces of a process that began with ordinary decisions inside homes. Historians may mark the end of a dynasty in one year, yet the underlying pressure may have traveled for decades, from weather to harvest, from harvest to debt, from debt to land loss, and from land loss to political unrest. This is why a climate event cannot be treated as a complete explanation, because the same poor season can produce adaptation in one society and breakdown in another, depending on storage, crop diversity, mobility, trade, inequality, leadership, and the willingness of people to share risk. Civilization is not reset when rain fails once. It is transformed when repeated environmental pressure reaches institutions that can no longer protect enough people to preserve the old arrangement. About 8,200 years ago, during the early Holocene, a marked cooling appeared in Greenland ice and in many other climate archives, making it a clear, abrupt climatic disturbance after the last ice age. The leading explanation begins far from the communities that would later feel its effects, in the enormous remains of the North American ice sheet, where glacial lakes had been held back as the ice slowly retreated. When a large volume of fresh water entered the North Atlantic, the surface ocean became less salty and less dense, which may have weakened the circulation that carried heat northward. Cooling parts of the North Atlantic region and shifting rainfall patterns beyond it, the event did not transform every place in the same way, and its timing, strength, and duration differ among ice cores, caves, lakes, and marine sediments. Yet, the evidence is coherent enough to show that a major reorganization occurred, especially around the North Atlantic. For human communities living at that time, there was no single experience called the 8.2000 year event. There were colder seasons, altered rain, changing plants, less predictable water, and different movements of animals. Some groups depended on hunting, fishing, and gathering, while others in Southwest Asia and nearby regions were already cultivating plants, keeping animals, and living in settled communities. These different ways of life created different forms of exposure. A mobile group could sometimes adjust its route or spend more time near reliable rivers and coasts, but movement still required energy, knowledge, and access to unoccupied or cooperative territory. A farming community could rely on stored food and shared labor, but a shortened growing season or repeated rainfall failure could threaten fields that had taken years to establish. Archaeological evidence from Europe and the Eastern Mediterranean does not reveal one synchronized abandonment or one universal collapse. Instead, it shows local responses that varied across landscapes. Some settlements changed size, some economic practices shifted, some communities moved, and others appear to have continued with limited visible disruption. Even where a change in settlement happened near the climatic event, dating uncertainty makes simple cause and effect difficult to prove. A site may have declined over generations. A climate archive may represent conditions across a wide area, and the two records may overlap without showing exactly how one influenced the other. In some coastal regions, fishing and shell gathering may have offered an additional buffer, while inland communities depended more heavily on rainfall, springs, grazing, or seasonal plants. So resilience was built from local combinations, rather than from one universal human response. This caution reaches back to the central question of human origins. Our species survived long before states existed, because flexibility was distributed through movement, varied diets, cooperation, and knowledge passed between generations. But no form of adaptation worked everywhere. Coastlines, forests, mountains, dry interiors, and river valleys placed separate limits on what people could do. The same climatic disturbance could therefore produce hardship in one region, opportunity in another, and little measurable change elsewhere. The event also reminds us that a major climate shock need not belong to a 1500-year clock. Its most widely discussed cause was a specific release of glacial freshwater created by the final retreat of a vast ice sheet, a condition that was not repeated in the same form throughout later civilization. It may fit loosely within lists of millennial changes, but its physical origin and regional expression cannot be reduced to one repeating schedule. What happened around 8,200 years ago was neither imaginary nor a global reset. It was a real disturbance, moving through connected oceans and atmospheres, then entering human life through local food, water, labor, and mobility. Its importance lies not in proving that civilization is periodically erased, but in showing how one planetary disruption can divide into many human histories, each shaped by the resources, relationships, and choices available in a particular place. Around 4,200 years ago, climate records from several regions show changes in rainfall, temperature, dust, or water availability, and this interval has become known as the 4.2 kiloyear event. Yet, the name can make a complex period sound more unified than the evidence allows, because no single global drought began everywhere at the same moment, lasted for the same length of time, or produced the same human consequences. Some records from the Eastern Mediterranean, Southwest Asia, parts of Africa, and South Asia indicate episodes of dryness, while other regions show weaker signals, different timing, or changes that cannot be described simply as drought. The event is therefore real as a subject of paleoclimate research, but its global form and historical meaning remain debated. This caution is especially important in discussions of the Akkadian Empire, Old Kingdom Egypt, the Indus civilization, and other Bronze Age societies, because political transitions near the same broad period have often been joined into one story of climate-driven collapse, yet the chronology is not precise enough to prove that one climatic disturbance brought all of these societies down together. The Akkadian political system weakened amid evidence of aridity in northern Mesopotamia. But historians and archaeologists also examine warfare, internal conflict, shifting settlement, economic strain, and the difficulty of governing distant territories. In Egypt, the end of centralized Old Kingdom rule involved political and regional changes that cannot be reduced to low Nile floods alone. And across the Indus region, urban life did not simply vanish in one sudden moment. Settlements shifted, populations redistributed, and economic practices changed over long periods. These examples show why climate may be understood as pressure rather than command. Reduced rainfall can lower harvests, weaken pasture, and make rivers less dependable. But the outcome depends on storage, trade, political cooperation, inequality, crop choices, and access to alternative land. This relationship reaches back to the earliest human communities whose survival never depended on climate alone, but on the ability to move, share information, change foods, and maintain relationships across uncertain landscapes. Bronze Age societies possessed larger stores, irrigation works, animals, roads, and administrative systems, yet these strengths also created obligations that required regular supplies. When rainfall weakened across several seasons, the burden could move from fields into taxes, debts, labor, migration, and conflict. Still, not every settlement declined, and some communities adapted by changing crops, relocating toward reliable water, reducing urban concentration, or strengthening local exchange. Archaeology often preserves abandoned buildings more clearly than successful adjustment, so the dramatic evidence of decline can overshadow quieter continuity. A village that became smaller may have survived better than a city that tried to preserve every institution, and a population that moved may have carried language, skills, seeds, animals, and family ties into another region, making apparent disappearance a form of reorganization. Written sources, where they survive, usually describe rulers, taxes, wars, or ritual concerns more clearly than ordinary adaptation, while climate archives describe physical conditions without revealing social decisions. Bringing the two records together requires restraint, especially when their dates overlap within ranges. The 4.2 kiloyear event also does not fit neatly into a perfect 1500-year rhythm because its timing varies among records and its causes may have involved different regional processes rather than one repeating mechanism. Treating it as a scheduled reset would erase the very evidence that makes it useful. Its importance lies in showing how a broad climatic disturbance can interact with societies already carrying political, economic, and environmental strain, producing different outcomes in different places. What appears from a distance as one age of collapse may be a mosaic of drought, adaptation, migration, political change, and cultural continuity. And the deeper lesson is that climate can narrow the choices available to civilization without deciding in advance which societies will break, which will transform, and which will continue under a different name. A single poor harvest can be painful, but many societies are built to survive one, because families keep seed, communities store grain, herders move animals, traders search for food elsewhere, and rulers may release reserves. The historical danger grows when difficult seasons arrive together and continue long enough to exhaust each layer of protection. One dry year can be remembered as misfortune, a second can consume what was saved, and a third can force choices that weaken the ability to recover. This is the difference between bad weather and a historical turning point. Not the severity of one season alone, but the way repeated stress removes alternatives. The late Hittite Empire offers a careful example. This powerful state occupied much of Anatolia and depended on farming, taxation, transport, administration, and political relationships extending across a wide territory. Evidence from ancient juniper timbers in central Anatolia indicates a longer trend toward dry conditions, followed by a short sequence of exceptionally poor growing years near the time when imperial authority disappeared. The evidence does not prove that drought alone destroyed the empire, and researchers do not possess a complete record of every field, storehouse, or decision. Yet several consecutive years of severe dryness could have placed extraordinary pressure on grain production and reserves, especially within a system already facing war, political strain, disrupted trade, and demands on distant provinces. Climate entered this world through ordinary dependencies. Rain had to reach fields at useful times, animals needed pasture, roads had to carry food, and institutions had to collect and redistribute supplies. When harvests weakened repeatedly, a central government could not create grain by decree. It could move existing food, demand more from regions that still produced it, or reduce the number of people it supported. But each response shifted hardship elsewhere. Written evidence from the wider eastern Mediterranean refers to grain shortages and requests for supplies during the closing decades of the Bronze Age. Though such texts cannot be matched perfectly to every climatic signal, they show that food security had become a political concern across connected societies. The deeper human pattern is much older. From the first communities onward, survival depended on maintaining enough energy, knowledge, and cooperation to bridge an uncertain season. Settled states expanded that bridge through granaries, roads, taxes, treaties, and long-distance exchange. But complexity could not remove biological limits. People still needed water and food each day, animals still required fodder, and workers weakened when supplies declined. Repeated shortages could therefore travel upward from households to institutions, reducing labor, encouraging migration, increasing debt, and making distant authority harder to maintain. A palace might remain standing while the network that fed it was already thinning. And when the political center finally failed, later observers could mistake the visible ending for the beginning of the crisis. The Hittite case is valuable because it shows both the importance and the limit of climate evidence. The dry sequence occurred near a major political transformation, but coincidence in time is not a complete explanation. Empires can survive drought when reserves, trade, leadership, and local flexibility remain strong, and they can fragment during moderate stress when those supports have already weakened. The same late Bronze Age disturbances produced different outcomes across neighboring regions. Some cities were destroyed, some declined gradually, some continued, and new communities emerged from older populations. This is why archaeology must follow not only ruins, but shrinking settlements, altered diets, interrupted imports, repaired walls, abandoned fields, and population movement. Because decline becomes visible through many losses before political names disappear, no synchronized hand reset the entire world. What became historically important was the meeting between repeated environmental pressure and a society whose protective systems could no longer absorb another loss. A run of bad years mattered because it arrived inside an existing structure of dependence, and because each exhausted reserve made the following year more dangerous than the one before. Around 1200 years ago, near the opening decades of the 9th century, the world contained no single civilized forests, grasslands, seas, and mountain systems, each with its own history of growth, strain, exchange, and political change. In Western Europe, communities lived through shifting kingdoms, changing trade, and the long aftermath of Roman fragmentation, while the Carolingian world was still trying to hold together wide territories through land and religion. Farther east, the Byzantine Empire organized cities, armies, taxation, and agriculture, while the Abbasid Caliphate connected regions from the Middle East toward Central Asia through commerce and urban life. In China, the Tang dynasty remained powerful, though it had endured rebellion, fiscal strain, military pressure, and changes in regional authority. Across South and Southeast Asia, states and trading networks drew strength from monsoon routes, river systems, and maritime exchange. In Mesoamerica, Maya cities followed different paths, some still flourishing, others already under pressure. And across Africa, communities adapted to local rainfall, pastoral movement, farming, mining, and trade in ways that left no single continental story. This diversity matters because the title places a possible climate turning point near this era. Yet a date alone cannot establish a global beginning, a cold decade in one region, a drought elsewhere, and a political crisis in a third may overlap without sharing one cause, and the records from this period are uneven. Some regions preserve written chronicles, others preserve tree rings, cave deposits, lake sediments, pollen, architecture, and settlement patterns. While many lives remain visible only through scattered material traces, the human foundations beneath these societies were far older than their states. The same needs that shaped the first communities still remained. Water had to be found, food had to be produced or gathered, children had to be protected, and knowledge had to pass between generations. But by the 9th century, these needs were embedded in larger systems of taxation, markets, roads, irrigation, tribute, warfare, and religious authority, making environmental change capable of traveling farther through connected institutions. A weak harvest could affect not only one village, but also the revenue of a ruler, the supply of an army, the price of grain in a town, and the stability of distant trade. Yet connection also created protection. Food could move between regions, merchants could redirect routes, and political centers could draw resources from broad territories. So complexity increased both fragility and resilience. This is why the world around 800 cannot be treated as if it stood at the edge of one synchronized reset. Some regions were expanding, some were fragmenting, and some were changing in ways not clearly tied to climate at all. Even where environmental stress can be identified, its timing often differs by decades or longer across separate archives, and local societies responded according to geography, institutions, population, and available alternatives. People still relied on the ancient human capacity to observe seasons, remember scarcity, cooperate, and move resources. But those capacities now operated through villages, courts, ports, monasteries, markets, and kinship networks extending beyond one landscape. A climatic disturbance could therefore be absorbed in one place and amplified in another, leaving no universal boundary between stability and crisis. What later looks like a single age was lived as many sequences of rain, harvest, taxation, conflict, recovery, and migration. The idea that the last cycle began 1200 years ago therefore requires more than finding crises near the 9th century. It requires evidence that a connected climate pattern appeared across many regions, and that the pattern continued beyond local weather or political coincidence. The first step is not to choose one collapse and force the world around it, but to look outward from this century and ask whether distant societies were actually entering the same environmental transition, or whether later observers have placed unrelated histories inside one convenient date. The name Medieval Climate Anomaly can sound as though the entire planet entered one long, warm season, but the evidence does not support such a simple picture. The term refers broadly to climate conditions during parts of the medieval centuries when some regions experienced intervals of unusual warmth, altered rainfall, or persistent circulation patterns, yet the timing and character of those changes differed from place to place. Northern Europe and parts of the North Atlantic often receive the most attention because historical records, tree rings, glacier evidence, and marine sediments suggest periods that were favorable for farming or travel in some areas. But even there, the climate did not remain steadily warm. Difficult winters, wet decades, storms, and local cooling continued within the wider interval. Farther away, temperature records reconstructed from trees, corals, lake sediments, caves, and ice do not reveal one moment when all regions warmed together. Some reached their warmest medieval conditions centuries apart, while others show changes in moisture more clearly than changes in temperature. This unevenness matters because civilization depended less on a global average than on the local arrival of rain, the timing of snowmelt, the strength of monsoons, and the reliability of rivers. A modest warming could lengthen a growing season in a cold northern landscape, while a related shift in atmospheric circulation could reduce rainfall somewhere else. One community might gain pasture as another lost water, and neither experience could stand for the whole earth. The same human dependence had shaped life since the earliest populations followed animals, plants, and seasonal water across changing terrain. But by medieval times, that dependence was held inside kingdoms, cities, farms, ports, irrigation systems, and trade routes, allowing a regional climate change to travel through prices, taxes, migration, and political relationships. A favorable sequence of seasons could support population growth and settlement. Yet it could also encourage people to cultivate land near the edge of reliability, creating greater exposure when conditions shifted again. The North Atlantic provides a useful example. Warmer sea conditions and changing atmospheric patterns may have supported Norse settlement and navigation during parts of the medieval centuries. But those developments also depended on ships, trade, livestock, political connections, and local decisions. Climate shaped possibilities without acting as the sole author of history. Elsewhere, monsoon variations affected parts of Asia at different times, while prolonged droughts influenced some regions of Mesoamerica, and African rainfall patterns followed their own complex paths. These events cannot be placed inside one clean sequence beginning around 1200 years ago. Because their strongest phases were not synchronized and their causes were not identical, modern reconstructions of the past 2 millennia show that pre-industrial warm and cold intervals were usually regional and asynchronous, unlike a single blanket passing across the globe. This does not make the medieval climate anomaly unreal. It makes it more precise. It was an age of significant climate variability, expressed through many regional histories. Rather than one global season, the proposed 1500-year rhythm therefore cannot be confirmed by pointing to medieval warmth as a worldwide starting signal. A true planetary reset would require clearer evidence of simultaneous change and shared human consequences. While the surviving records show overlapping but uneven shifts, some societies adapted, some expanded, some contracted, and many changed for reasons that climate alone cannot explain. The deeper question is not whether one medieval climate arrived everywhere, but why later history has gathered many separate environmental changes beneath one name, turning a landscape of different times and places into the appearance of a single global age. When the evidence asks us to imagine a mosaic, each tile recording a balance of heat, rain, wind, water, food, and human response, preserving that unevenness keeps the central question open and places 1200 years ago within a changing world, not at the instant when a hidden climate clock supposedly reset civilization across the inhabited world. Around 1200 years ago, the North Atlantic, monsoon Asia, and Mesoamerica were not entering one shared climate age. Even though each region experienced important environmental change, in the North Atlantic, conditions during intervals of the medieval centuries sometimes favored longer growing seasons, navigation, and settlement in northern lands. But those opportunities were uneven and temporary because storms, sea ice, poor soils, and colder intervals continued to limit life. Norse communities in Iceland and Greenland depended not only on temperature, but on livestock, trade, political ties, and access to marine food. So climate shaped the boundaries of survival without determining every outcome. In monsoon Asia, the central question was often not warmth alone, but the timing and strength of seasonal rain, because farming systems, rivers, reservoirs, and dense populations depended on water arriving within a useful portion of the year. Cave deposits, lake sediments, and historical records indicate that monsoon behavior varied across centuries and regions, bringing wetter conditions to some places, drier conditions to others, and changes that did not begin everywhere together. Powerful states could expand irrigation, move grain, or organize labor. Yet those same systems became vulnerable when several seasons failed and political institutions could no longer distribute water or food effectively. In Mesoamerica, prolonged drought affected areas of the Maya world during the final centuries of the first millennium, but the pattern was neither one drought nor one simultaneous collapse. Some cities lost population, some political centers weakened, some communities moved toward more reliable water, and others continued or grew. Warfare, dynastic rivalry, land use, trade, and local geography all influenced what followed. The deep human connection beneath these three histories remained the same as it had been since the earliest communities. Bodies required water, food, shelter, and cooperation, yet the social structures built around those needs had become very different. A Norse farm near the North Atlantic depended on pasture, stored fodder, ships, and exchange. An Asian rice region depended on seasonal rain, canals, labor, and river management, while a Maya city depended on local rainfall, reservoirs, cultivated land, and political systems capable of organizing resources. A change in atmospheric circulation could therefore move through each society by a different route. Colder seas might shorten travel in one region, weaker monsoon rain might reduce harvests in another, and repeated dry seasons might lower stored water elsewhere. None of these experiences can stand as evidence that civilization was reset everywhere on one schedule. The dates do not align closely enough, the physical mechanisms differ, and the social outcomes range from adaptation to migration, political fragmentation, continuity, and recovery. This comparison also shows why a global label can conceal local time. One region may experience its greatest stress, while another enjoys favorable conditions, and a society may begin changing decades before the climate signal reaches its strongest point. Historians often see the ending of a dynasty or the abandonment of a city, but environmental pressure may have accumulated slowly through ordinary harvests, household decisions, and repairs that became harder to complete. This is also why apparent coincidence must be treated carefully, because a drought dated within a range may overlap a political crisis without proving cause, while evidence from another region may carry a different margin of uncertainty. The closer these records are examined, the less they resemble three hands moving around one clock, and the more they reveal societies negotiating separate limits within a connected but uneven Earth. What began around the 9th century was therefore not one worldwide reset, but a period in which several regional climate systems followed their own paths, intersecting with societies whose strengths and weaknesses had been built over many generations. The meaningful pattern lies not in synchronized collapse, but in the repeated fact that climate becomes history only after passing through geography, food systems, institutions, and human relationships. Each region transformed the same planetary atmosphere into a different human consequence. Geography divided climate risk long before maps gave names to regions, because water, elevation, soil, coastlines, forests, and distance from trade shaped what each community could endure. A society built beside one great river might appear secure while the river followed its familiar rhythm. Floodwater could renew fields, irrigation could spread moisture, and boats could move grain between settlements. Yet, dependence on one river also concentrated danger. If floods arrived too low, too high, or at the wrong season, the same system that supported dense population could expose many people at once. Canals, embankments, and storage could reduce the damage, but they required labor, maintenance, and cooperation across a wide area. A community on a plateau faced another balance. Higher ground might protect fields from river floods, but rainfall could be less reliable, soils thinner, and winters colder. Pastoral movement might offer flexibility where farming alone could not, allowing animals to follow seasonal grass, though drought could close distant grazing routes and bring herders into competition around remaining water. Along coasts, the sea offered fish, shellfish, salt, transport, and exchange. Marine food could soften the failure of crops, yet coastal life carried its own risks through storms, changing shorelines, erosion, and the loss of safe harbors. A settlement with access to several ecological zones often possessed more alternatives than one, depending on a single crop or water source. Forest, river, grassland, coast, and upland could each provide different foods at different times. Diversity did not remove scarcity, but it distributed the danger. This pattern reaches back to the earliest human communities, whose survival often depended on moving between landscapes rather than trusting one place to provide everything. Archaeology suggests that people repeatedly used boundaries where environments met, because such places could offer varied plants, animals, stone, wood, and water within reachable distance. That ancient advantage continued after farming, although it became embedded in roads, markets, seasonal labor, and political borders. A city near navigable water could import grain from a region that still had rain, while an isolated inland settlement might have fewer choices. A mountain community could escape heat affecting the lowlands, yet become vulnerable if snow, springs, or passes changed. Geography did not determine fate, but it set the range of possible responses. It also shaped how quickly stress became visible. In a river kingdom, falling water could affect taxation, transport, and harvests across many districts. In a scattered coastal economy, losses might be divided among fishing villages, farms, and ports, making decline slower and less uniform. The same climate disturbance could therefore look like sudden political crisis in one place and gradual adjustment in another. Human institutions mattered because they decided whether geographic advantages were shared. A reservoir protected only those allowed to use it. A trade route helped only while goods could move safely and communities had something to exchange. Fertile land could support reserves, but inequality might place those reserves beyond the reach of vulnerable households. Geography created opportunities, social organization decided who could use them. When historians compare societies separated by oceans and centuries, this local structure must remain visible. A drought recorded in a cave cannot be treated as the same event for every population within a broad region. Distance from water, crop choice, elevation, storage, and access to neighboring lands could change the meaning of the same reduction in rainfall. Even neighboring communities could experience opposite outcomes when one possessed a spring, protected harbor, or exchange partner that the other lacked, reminding us that resilience was often measured in geographic differences rather than in the age of a civilization. The idea of a repeated civilizational reset becomes less convincing at this scale, because the Earth does not present climate pressure to humanity through one doorway. It enters through riverbanks, wells, grazing routes, fishing grounds, mountain passes, and fields. And each doorway leads into a different arrangement of bodies, work, memory, and power. Adaptation often leaves a quieter trace than collapse, because ruins announce themselves while successful adjustment may look like disappearance, simplification, or movement. A palace burned by fire can survive for millennia as a dramatic layer of destruction, yet a farming community that changes crops, shortens its fields, or moves closer to water may leave only a thinner scatter of tools and houses. Archaeology is therefore more likely to preserve the visible failure of large structures than the ordinary decisions that allowed people to continue living. When a city loses population, its empty streets can suggest that an entire society vanished, but many of its former inhabitants may have settled in smaller villages, joined relatives elsewhere, or reorganized work around new sources of food. Their survival does not create a monument. It creates continuity that is harder to see. This difference reaches back to the earliest human communities. Mobile groups rarely built stone walls or deep foundations, yet their ability to change routes, diets, and seasonal camps helped human populations persist through environments that repeatedly shifted. Later societies used similar flexibility in more settled forms. Farmers planted varieties suited to drier ground, herders altered grazing patterns, households combined cultivation with fishing or gathering, and traders redirected exchange toward regions where food remained available. Water could be stored in smaller local systems rather than one large canal. Families could divide between town and countryside, spreading risk across more than one landscape. None of these responses guaranteed security, and some may have involved severe hardship, but they could prevent environmental pressure from becoming complete social breakdown. The difficulty is that adaptation often reduces archaeological visibility. A large administrative center produces written records, monumental buildings, imported goods, and concentrated waste. A network of smaller settlements produces fewer of these signs, even when the people within it preserve language, skills, crops, and relationships. Historians may describe the decline of urban life, while the descendants of urban residents experience a long transition into more local forms of survival. This is why settlement contraction must not automatically be treated as cultural extinction. The loss of distant trade can narrow material variety without erasing knowledge. The abandonment of public buildings can weaken political authority, while households continue ordinary work. Even changes in pottery, diet, or burial practice may reflect adaptation, migration, or new identities, rather than the arrival of an entirely separate population. Climate pressure can encourage these changes by making old systems too expensive to maintain. A canal serving distant fields may require more labor than a shrinking population can provide. A crop that once produced reliable surplus may become less suitable as rainfall changes. A city dependent on imported grain may become vulnerable when neighboring regions face the same shortage. In response, people may choose smaller settlements, mixed food sources, and shorter supply lines. From the viewpoint of a state, this can resemble decline. From the viewpoint of survival, it may represent a workable reduction in complexity. The oldest human advantage was never the ability to preserve every institution unchanged. It was the ability to carry useful knowledge into new conditions and release practices that no longer worked. Civilizations inherit that capacity, though power, property, and social hierarchy can make change slower and more unequal. Those with land or stored food may resist transformation, while poorer households adapt first because they have fewer protections. The archaeological record may later preserve the abandoned estate more clearly than the improvised village that outlasted it. Climate history, therefore, appears full of sudden endings, partly because endurance is often quiet. People who remain alive by moving, sharing, reducing, and rebuilding leave fewer dramatic marks than the walls they no longer need. A true understanding of resilience must learn to see absence not only as loss, but sometimes as evidence that human life continued beyond the place where history expected to find it across generations, even when monuments and governments disappear. A state can disappear while the people beneath it continue to wake, work, eat, marry, remember, and raise children. Because political systems are only one layer of human life, kings can lose authority, tax networks can break, armies can no longer be supplied, and administrative centers can fall silent. Yet farmers may still plant familiar seeds, Herders may still follow seasonal routes, craftspeople may still shape tools, and families may still speak the same language around the same fires. This difference is often hidden by the way history is written, because written records tend to follow rulers, capitals, wars, and institutions. While ordinary continuity leaves fewer dates and fewer names, when a dynasty ends, the event can be marked clearly, but the slow survival of villages may continue without a single moment that appears important enough to record. Archaeology can reveal this quieter persistence through houses rebuilt on simpler foundations, local pottery replacing imported goods, burial customs continuing after royal symbols vanish, and food remains showing that people adapted their diets without abandoning the region. Climate pressure may contribute to the weakening of a state by reducing harvests, disrupting transport, or making taxation harder to collect, but it does not automatically erase the communities that once supported that state. People may move away from exposed centers toward smaller settlements, join relatives in safer regions, or depend more heavily on local exchange. From the viewpoint of the old government, this is fragmentation. From the viewpoint of human survival, it can be reorganization. The distinction reaches back to the earliest origins of our species, long before states existed. Human groups survived because knowledge, care, and cooperation did not depend on palaces, borders, or official institutions. They depended on memory carried between generations, on practical skills repeated by hand, and on relationships strong enough to share food, shelter, and information. Later civilizations added roads, laws, storage systems, temples, armies, and markets. But the older foundations remained beneath them. When the upper structure failed, those deeper forms of continuity could still support life. This does not mean collapse was gentle. Political breakdown could bring violence, hunger, forced migration, loss of property, and the disappearance of services that had taken generations to build. Yet even severe disruption rarely returned everyone to the same beginning. Descendants inherited languages, crops, tools, stories, and habits formed under the previous order. New states often use roads, fields, irrigation works, and administrative ideas left by those before them. So what appears to be a reset is usually an unequal transfer. Some knowledge is lost, some survives, some becomes local, and some is absorbed into a different political system. Climate may accelerate this transfer by making the old arrangement too costly to maintain. A capital dependent on distant grain can weaken while villages near reliable water continue. A large irrigation network can fail while smaller channels remain useful, and a trade system can contract while local markets become more important. The map of power changes faster than the map of ancestry because populations do not vanish simply when rulers lose control. This is why abandoned monuments can mislead. Stone preserves the silence of institutions more clearly than soil preserves the movement of families. A ruined palace can dominate the story, even when most people lived outside it, and an empty ceremonial center can be mistaken for the end of a culture whose descendants continued elsewhere, carrying names, beliefs, crops, and skills into new communities. The deeper human pattern is not one of repeated return to zero, but of continuity passing through broken forms. Civilization may lose its center, its scale, or its political name, while the people who sustained it reshape daily life around smaller networks, different landscapes, and more limited expectations. So when climate appears to reset a civilization, the more careful question is not whether a state survived, but how much human continuity remained after the institutions that once made it visible had disappeared. Climate pressure becomes dangerous to a society only after it passes through the biological limits of the people who must carry that society each day, because fields, roads, walls, armies, markets, and rituals all depend on bodies capable of working, walking, thinking, recovering, and caring for others. When water becomes harder to reach or food becomes less reliable, the first effects may be too small to appear in political records. Meals become slightly smaller, journeys become longer, rest becomes shorter, and more time is spent finding what was once nearby. A community can absorb this for a season, especially when food is stored, relatives share supplies, and work can be reorganized. But if scarcity continues, the margin between effort and recovery begins to narrow. Adults may have less strength for planting, repairing, herding, transporting, and defending. Children may become more vulnerable to poor growth. Older people may need more support, and illness or injury can remove labor that the group can no longer easily replace. None of these outcomes is automatic, and no single skeleton can reveal the complete experience of a population, because growth, disease, diet, workload, genetics, and burial practices all affect what survives in bone. Yet, when many forms of evidence point in the same direction, changing diets, reduced stature across generations, signs of nutritional stress, altered settlement patterns, fewer births, or movement toward reliable water, researchers can begin to see how environmental pressure entered the human body before it entered the history of states. This connection reaches back to the earliest human communities, whose survival depended on balancing energy gained from food against energy spent on movement, care, tool-making, and protection. Mobility could spread risk across space, but it also demanded strength, knowledge, and access to new territory. Settled life changed the balance by allowing storage and cooperation at larger scales, while also concentrating more people around fixed fields and water systems. The biological threshold was therefore never a single number shared by all societies. It depended on age, diet, disease environment, workload, social support, and the distribution of resources. A wealthy household could preserve food while a poorer one crossed into crisis. A city might maintain soldiers and officials while nearby farmers reduced meals, and an authority could appear stable even as the population supporting it weakened. This inequality matters because a society can lose resilience from below before its institutions visibly fail. Fewer healthy workers mean less land cultivated, fewer canals repaired, fewer animals tended, and less food carried to market, which reduces the resources available for the next season, creating a feedback in which biological strain becomes economic strain, and economic strain returns as deeper biological pressure. Migration can interrupt this process if people reach safer land, but movement itself costs energy and may expose families to conflict, unfamiliar foods, or the loss of social support. The same ancient capacities that helped humans survive changing climates, cooperation, memory, flexible diets, and shared care still matter here, yet they cannot produce calories or water where none remain. They can only extend the time before limits are reached. Stored grain, imported food, public relief, crop diversity, and temporary movement can delay that crossing, but their protection depends on fair access, functioning transport, and enough time to respond. This is why climate does not reset civilization at the moment rainfall declines. The decisive change comes when enough bodies can no longer sustain the labor, care, and trust required to keep the old system functioning. And even then, the result may be movement, smaller communities, or political transformation rather than disappearance, because human populations often preserve life by reducing the scale of what they are trying to maintain. The biological threshold is therefore not the end of humanity, but the point at which a society must change its demands on human bodies, or accept that those bodies will no longer be able to carry the civilization built upon them. A city can survive a poor harvest only if food from somewhere else can still reach it, because large settlements rarely feed themselves from the ground beneath their streets. They depend on fields beyond the walls, roads crossing difficult land, boats moving along rivers or coasts, storehouses protecting grain, animals carrying loads, officials recording supplies, an agreement strong enough to keep all of these movements functioning. When climate pressure reduces production in one region, trade can spread the burden by drawing from another, but that protection works only while the network remains wider than the shortage. If drought reaches several farming zones at once, if floods damage roads, if storms delay ships, or if conflict closes a route. The distance between food and hunger can become more important than the total amount of food that still exists. A warehouse may remain full while a neighborhood goes without. Grain may be available in another province while transport animals lack fodder. Merchants may know where supplies can be purchased while prices rise beyond what ordinary families can pay. This is the supply network threshold, the point at which a society still possesses resources, but can no longer move them reliably through the system built to distribute them. The same principle existed at the beginning of human life, when early communities depended on paths connecting water, stone, plants, animals, and neighboring groups. A broken route could isolate people from something essential, but mobile groups often had fewer links that had to operate at the same time. Cities and states gained enormous strength by connecting many regions, yet each connection created another condition that had to remain stable. Roads required repair, bridges required labor, canals required cleaning, ports required safety, records required trusted authorities, and long-distance exchange required partners who also had something to spare. A complex society can therefore absorb one damaged link by using another. But when several links weaken together, the protective network can become a channel through which crisis spreads. A failed harvest raises prices. Higher prices increase debt. Debt reduces household reserves. Reduced reserves weaken workers. Weaker labor slows transport and repair. Delayed transport creates further scarcity, and fear encourages hoarding. Every response makes sense locally, yet together they can reduce the movement on which the whole system depends. Political authority may try to control prices, seize grain, redirect shipments, or prioritize armies and cities, but these choices decide who receives protection and who is left exposed. If people believe distribution is unfair, they may hide supplies, resist officials, abandon markets, or leave the region. Trust then becomes a form of infrastructure as necessary as roads and storehouses. Because grain moves through promises before it moves through gates, historical records often preserve taxes, shipments, and royal orders, while archaeology preserves storage buildings, imported goods, and abandoned routes. But neither record captures every informal exchange between relatives, villages, and local traders. These smaller networks can sometimes preserve life after official systems weaken, just as the earliest human groups survived through relationships beyond any central authority. A civilization does not cross the supply threshold because one road closes. It crosses when enough routes, reserves, institutions, and agreements fail that ordinary circulation cannot be restored before biological need becomes urgent. Climate may begin the pressure by reducing harvests or damaging transport, but social structure determines whether food moves towards scarcity or remains concentrated behind distance, price, and power. And once movement fails, a society can appear to collapse even while resources still exist somewhere inside it, unreachable by the people whose labor once kept the network alive. The final danger is not emptiness, but separation, because survival depends on bringing distant abundance into contact with immediate need. And when that contact is broken across too many places, the network designed to protect a population can preserve its own structures longer than it preserves the people who gave those structures daily, meaning political systems begin to weaken when environmental pressure is no longer experienced as a shared hardship, but as an unequal burden. Because people can endure scarcity longer when they believe sacrifice is temporary, distribution is fair, and those with authority are protecting the whole community. Yet the same drought or harvest failure can become politically dangerous when grain remains in protected storehouses. Taxes continue to be collected, armies receive supplies before villages, or wealthy households preserve reserves while poorer families sell land, animals, and future labor. Climate does not create inequality, but it can expose and deepen it, turning an environmental shortage into a struggle over who must absorb the loss. The political threshold is reached gradually, first through complaints, delayed payments, hidden stores, local migration, and resistance to demands that once seemed normal, rulers may respond by reducing taxes, releasing food, moving supplies, repairing water systems, or negotiating with neighboring regions. And these actions can restore trust if they arrive early enough, but authorities may also increase extraction to maintain armies, courts, monuments, or distant officials. Protecting the visible center while weakening the communities that support it, this can preserve the appearance of stability for a time, even as the social foundation narrows beneath it. The pattern has deep roots in human history, because the first communities survived uncertain environments through reciprocal care and the sharing of risk. No central state organized that cooperation, but relationships still depended on memory, obligation, and the expectation that help given in one season might be returned in another. Later civilizations expanded those expectations into taxes, laws, granaries, irrigation systems, and public authority, creating the possibility of protection at a much larger scale, while also creating distance between those who produced food and those who decided how it would be used. When climate pressure reduced what was available, that distance could become politically important. Farmers might see officials demanding grain during shortage, towns might receive supplies while rural districts emptied, and peripheral regions might stop recognizing a government that could collect but no longer protect. Conflict then becomes more likely, not because drought commands violence, but because scarcity reduces the number of solutions that satisfy everyone. Rival leaders can promise relief, local elites can challenge central authority, armies can compete for remaining supplies, and displaced populations can enter regions already under strain. Each response may begin as an attempt to survive, yet together they can weaken the agreements that once held the wider society together. Written records often describe rebellion, invasion, unpaid tribute, or the fall of rulers, while the environmental pressure behind these events remains visible only through tree rings, lake deposits, pollen, or abandoned fields. Combining the records requires care, because political conflict can occur without climatic stress, and difficult climate can occur without political collapse. The connection becomes strongest when several lines of evidence show that shortage, institutional strain, and social division intensified within the same broad period. Even then, climate should be understood as an amplifier, not a hidden ruler of history, a flexible state with trusted institutions, varied food sources, and fair relief may survive years of environmental difficulty, while a divided state may fragment under a smaller shock because people no longer believe the old system deserves their labor or obedience. This is why civilizations do not reset together. Their political thresholds are built from different histories of power, cooperation, inequality, and memory. Two societies can face similar rainfall and reach opposite outcomes. One, reorganizing around local support, the other exhausting itself while defending an arrangement that no longer distributes survival effectively. The final break often comes when enough people stop seeing the central system as the safest place to remain and begin protecting family, village, region, or rival authority instead. At that moment, climate has not destroyed civilization by itself, but it has helped reveal that the political structure can no longer convert shared danger into shared protection. And once that trust is gone, even the return of rain may not restore the world that existed before. When a city begins to shrink, the first visible change may be silence in places that once concentrated labor, trade, ceremony, and authority. Fewer carts enter the gates, fewer roofs are repaired, workshops produce less, imported goods become rare, and buildings designed for crowds stand partly empty. Yet this quiet does not mean that everyone has disappeared, because people often leave large centers gradually, following relatives, water, safer land, smaller markets, or regions where food remains more reliable. And the movement can be so dispersed that archaeology records the abandoned city more clearly than the communities formed beyond it. A household may divide, with some members remaining near fields while others move toward a port, upland pasture, river crossing, or neighboring village. Another family may join a settlement where marriage ties or shared language provide protection, and groups once dependent on urban distribution may return to more local exchange, mixed farming, herding, fishing, or seasonal labor. From the viewpoint of the old state, this looks like decline because taxes fall, public works slow, armies lose recruits, and rulers control less territory. But from the viewpoint of ordinary survival, movement may be the most rational response to a system that no longer brings food, water, security, or opportunity close enough to daily life. This pattern reaches back to the earliest human populations, whose ability to move between environments allowed knowledge and relationships to survive after one place became less useful. Later urban societies carried more possessions, deeper attachments, and stronger political obligations. So leaving was harder, but the old human capacity to redistribute life across space never disappeared. Climate pressure could accelerate that redistribution by lowering harvests, changing river flow, damaging transport, or making one region less reliable than another. Yet the destination and outcome depended on roads, borders, kinship, available land, and the willingness of receiving communities to share resources. Migration was therefore not a simple escape. It could involve hunger, conflict, loss of status, unfamiliar work, and the separation of families. Some migrants settled permanently, some returned when conditions improved, and others moved repeatedly across generations, creating a population map that no single moment of collapse can capture. Archaeological evidence may show houses becoming smaller, imported pottery declining, storage practices changing, and settlements appearing in places that were previously less important. These signs can indicate a reduction in political complexity without a reduction in human intelligence, memory, or cultural continuity. People may abandon monumental centers while preserving farming knowledge, craft traditions, songs, rituals, names, and family obligations, and new communities may use materials taken from older buildings, turning the physical remains of one political order into the foundations of another. The idea of a reset becomes misleading here, because the city may lose its scale while the population survives in altered form, and the apparent emptying of one landscape may coincide with growth elsewhere. Climate can help shift the balance between center and periphery, but it does not erase the paths connecting them. When large supply systems fail, shorter routes may become safer. When central storage becomes unreliable, household reserves may matter more. And when distant authority weakens, local leaders, councils, or kin networks may take over functions once managed from the capital. None of this guarantees peace or prosperity, yet it shows that collapse is often a change in concentration rather than a return to nothing. The people who leave carry the living substance of civilization with them, even when the city that once made them visible falls into ruin. Over time, this dispersal can make later historians imagine a sudden break, because records stop where administration stopped, while births, marriages, harvests, and exchanges continue beyond written view. Descendants may live under another ruler or within smaller communities, still carrying fragments of the older world into landscapes, showing that the fall of urban concentration is not necessarily the fall of a people, but the relocation of their history. When a political center disappears, knowledge does not vanish in the same way that walls fall, because much of what keeps a society alive is never stored in one building, one archive, or one ruling class. It exists in hands, habits, spoken language, cultilim, plants, remembered routes, shared measurements, and repeated forms of work. A palace may contain records of taxes, treaties, and official ceremonies. But a farmer knows when local soil can be planted. A herder recognizes the condition of animals, a potter understands clay and fire, and a family remembers which foods can be preserved through a difficult season. These forms of knowledge are less visible to history because they are carried through practice rather than monuments. Yet they often survive the collapse of the institutions that once surrounded them. Climate pressure can weaken the centers that collect and organize knowledge, especially when grain, labor, transport, and taxation decline. Scribes may no longer be supported, schools may close, specialists may disperse, and written archives may be damaged or abandoned. Real losses can follow, techniques may disappear, texts may be forgotten, and complex systems that depend on many trained people may become impossible to maintain. But the loss is rarely complete. Descendants continue to cook, build, cultivate, repair, exchange, and speak, carrying pieces of the older order into smaller communities. A seed variety can preserve generations of observation without recording a single sentence. A building method can survive through imitation, and a word can outlive the state that once used it in law. This continuity reaches back to the beginning of human culture, long before writing, when every useful skill depended on teaching through demonstration, memory, and correction. Early humans survived because knowledge could move between bodies and across generations, and that ancient method remained beneath later civilizations even after libraries, temples, workshops, and courts appeared. When centralized systems weakened, knowledge often returned to these quieter containers: households, local specialists, kin groups, religious communities, and villages. The process was not smooth or equal. Some people carried more knowledge than others. Some traditions were interrupted by migration or violence. And some skills required materials or institutions that no longer existed. A large irrigation network could not be preserved by memory alone if labor and political coordination had disappeared. A metalworking tradition could decline if trade no longer delivered ore, and a written language could narrow if fewer people were trained to read it. Climate, therefore, could contribute indirectly to cultural loss by reducing the surplus that supported specialists and long networks. Yet, even then, fragments often survived and later entered new systems. Roads were reused, tools were copied, stories were adapted, and administrative practices were absorbed by successor states. What changed was not only the amount of knowledge, but the place where it lived. A technique once managed by officials might become local, custom. A formal calendar might survive as seasonal memory, and a crop once distributed through imperial storehouses might continue in family fields. From a distance, this can look like a return to simplicity, but simplicity is not the same as ignorance. Smaller communities may preserve exactly the knowledge needed for their landscapes, while releasing institutions too costly to maintain. The idea of a civilizational reset becomes misleading because it imagines knowledge as a structure that collapses all at once, when in reality, knowledge is distributed unevenly across people, materials, landscapes, and generations. Some of it can be destroyed in a day, some can survive for centuries without writing, and some can reappear in a new political world under another name. Climate may change the container, reduce the scale, and break the networks that once made knowledge visible, but it cannot automatically erase every memory held in the ordinary actions through which human beings continue to make life possible. Across repeated migrations, new settlements, altered languages, and changing forms of authority, inherited knowledge can remain incomplete yet sufficient, allowing descendants to begin not from nothing, but from fragments already shaped by earlier lives. History prefers a date because a date can be placed on a page, but human life rarely changes at the speed of a single year. A dynasty may end when a ruler dies, a capital falls, or the last inscription is made, yet farmers may continue planting, families may continue speaking the same language, and local customs may survive long after the political name has disappeared. The sharp line belongs to the record, while the gradual transition belongs to the people who lived through it. Climate history creates the same illusion. A drought may be assigned a beginning and an end, but its effects can arrive unevenly. One valley may lose rain first, another may remain productive for years, and a city may not feel the shortage until grain prices rise or trade routes weaken. By the time a historian marks collapse, many households may already have changed crops, reduced herds, divided families, or moved towards safer water. The ending that appears sudden from above may have been experienced below as a long sequence of smaller adjustments, none of them large enough to seem like the final break. This pattern reaches back to the earliest human communities who did not organize time through dynastic lists or official chronologies. They experienced change through seasons, migrations, births, deaths, food, and memory. A route became less useful, a plant returned less often, a shoreline shifted, and knowledge adapted through repeated practice. Later civilizations built calendars, archives, and political offices. But daily life still moved through the same human scale. People noticed whether the well filled, whether the seed grew, whether relatives returned, and whether the next winter could be survived. This is why the word reset can mislead. It suggests that one system stops and another starts cleanly, when in reality, old and new arrangements often overlap for generations. A weakened state may still collect taxes in some districts, local leaders may govern others, old laws may remain in use, and new trade routes may grow beside roads that are no longer maintained. Children can be born into a world containing fragments of two political orders, learning customs from the past while adjusting to conditions their grandparents did not know. Archaeology captures this overlap through repaired buildings, reused materials, mixed pottery styles, changing diets, and settlements that shrink without becoming empty. Written records may stop because scribes are no longer supported, yet silence in the archive is not silence in life. Climate can accelerate these transitions by making old systems harder to maintain, but it seldom provides a clean boundary. A river may decline over decades, soil may lose productivity gradually, and repeated harvest failures may weaken institutions long before the palace is abandoned. The same environmental pressure can also continue after political collapse, meaning that the official ending of a state does not mark the end of the climate problem. People who move into smaller communities may face the same dry years with fewer resources but more flexible obligations, while others may find new landscapes where the pressure is reduced. The transition continues across space as well as time, and no single date can contain it. Historians need boundaries to compare periods, yet those boundaries should not be mistaken for natural walls. The fall of a city, the end of a dynasty, and the disappearance of a written name are useful markers, but they are only moments within longer human processes. Civilization changes through accumulation. As habits weaken, routes shift, institutions lose reach, and new forms of cooperation become ordinary. What looks like a reset from centuries away may have felt like adaptation without a clear beginning, loss without a final ending, and continuity hidden inside change, leaving the deeper question of whether climate ever resets civilization at all, or whether human history simply crosses thresholds too slowly for those living through them to recognize when one world has already become another. A number drawn from the past can feel like a warning, especially when it appears more than once, but an average interval is not a date waiting on the future. The proposed rhythm near 1500 years emerged from patterns in selected climate records, particularly around the North Atlantic, where layers of ice, ocean sediment, and drifting debris suggested repeated changes on a millennial scale. Some studies have treated this spacing as evidence of recurring climate behavior, while others have shown that irregular events, uncertain dating, and internal variability can produce a similar statistical pattern without any precise external clock. Both possibilities leave one conclusion unchanged. The record cannot tell us that another civilizational reset must occur after a fixed number of years. Natural systems contain memory, thresholds, and feedbacks. Oceans store heat, ice changes the balance of fresh and salt water, winds shift, and disturbances can move between atmosphere and sea. These processes may return to related states, but the background climate is never exactly the same. The size of ice sheets changes, coastlines move, vegetation alters the land surface, and the distribution of heat between regions evolves. A mechanism active during the last glacial period may weaken, disappear, or behave differently during the Holocene. Even within one climatic age, two similar disturbances can produce unequal results because the system begins from different conditions. This makes recurrence possible without making predictions simple. The same caution applies to human history. The first human populations did not encounter climate as a numbered sequence. They encountered changing water, animals, plants, cold, and distance. Their responses depended on mobility, cooperation, knowledge, and access to alternative landscapes. Later societies added fields, cities, markets, canals, roads, and states, but they did not become passengers on a universal calendar. They became more dependent on local environments and more connected to distant supplies. A climatic change could therefore spread widely through trade and politics, yet its consequences still depended on geography, inequality, institutions, and the condition of each population. If one society weakened near a proposed millennial interval, that timing alone cannot show that the interval caused the crisis. Many societies experienced droughts without collapsing, and many states failed during periods that do not fit the pattern. Selecting only the events that resemble the expected spacing creates a cleaner rhythm than the full historical record contains. The phrase that the last cycle began 1200 years ago adds another layer of certainty that the evidence does not provide. Medieval climate changes were regionally important, but their strongest phases did not begin simultaneously across the world. Some places became warmer, others drier, wetter, or colder, and many changes unfolded at different times. There is no agreed global marker from the 9th century that can be identified as the beginning of a countdown. A cycle can describe a tendency in past data without functioning as a forecast, just as the average distance between storms does not identify the day of the next storm. This distinction protects both science and history from false precision. It allows researchers to study repeated behavior without turning uncertainty into prophecy, and it allows listeners to recognize genuine climate risk without believing that every drought, migration, or political crisis belongs to one predetermined sequence stretching across all continents and every generation alive. The useful lesson is not that civilization has 3 centuries remaining before an automatic reset. It is that natural variability can place long pressure on systems that mistake recent stability for permanence. Human societies are safest when they understand uncertainty, preserve alternatives, and avoid building every essential need around one fragile expectation. The ancient record offers no scheduled ending, but it does reveal a recurring vulnerability. Generations inherit institutions shaped by climates they assume will continue. When those assumptions fail, the outcome is decided not by a hidden clock, but by how much flexibility, trust, knowledge, and shared protection remain before change arrives. The modern climate is not simply the medieval world returning on schedule, because the forces shaping present warming, the pattern of change, and the speed at which it is unfolding are not the same as the regional variations preserved from earlier centuries. Natural climate variability has always existed. Oceans exchange heat with the atmosphere, volcanic eruptions can cool the surface for a time, solar energy changes, and winds move warmth and rainfall between regions. Yet, measurements and physical evidence show that modern warming is driven mainly by greenhouse gases released through human activity, especially fossil fuel burning and land use change. These gases reduce the amount of heat escaping to space, altering the energy balance of the planet rather than merely shifting warmth from one region to another. This distinction matters because the medieval climate anomaly was not a synchronized global temperature rise. Its warm and dry intervals appeared at different times across different landscapes, while modern warming is measured more clearly across the atmosphere, oceans, land, ice, and many ecological systems. Natural influences still affect years and decades, but they do not explain the long upward trend by themselves. The oldest human communities lived within natural variation and survived by adjusting movement, diet, cooperation, and knowledge to changing local conditions. Later civilizations added storage, irrigation, trade, and political organization, but the modern world has added another condition without historical precedent in the same form: Billions of people now depend on connected systems of energy, agriculture, transport, water, finance, and communication that operate across continents. This connection can move food and assistance toward regions under stress, yet it can also transmit disruption far beyond the place where heat, drought, flood, or crop loss first appears. A damaged harvest can influence prices elsewhere, a closed river route can delay industry, and strain on one power network can affect hospitals, homes, and supply chains. Climate risk therefore enters modern life through old biological needs and new layers of dependence. People still require water, food, shelter, and tolerable conditions for work, but obtaining them often depends on infrastructure built for climate ranges observed during recent generations. The danger is not that an ancient clock has reached a predetermined stage, it is that human activity is changing the background conditions within which natural variability continues to operate. A drought can occur naturally, yet warmer conditions may alter evaporation and soil moisture. Heavy rainfall can occur naturally, yet a warmer atmosphere can hold more water, and coastal storms can occur without human influence. Yet, rising seas can increase the reach of flooding. None of these relationships means every event has one simple cause. Attribution requires careful analysis, but uncertainty about individual events does not erase the well-established cause of the longer global trend. This also changes the meaning of adaptation. Earlier societies could sometimes move toward another valley, river, or coast, while modern borders, dense populations, infrastructure, and land ownership can make movement more difficult. At the same time, scientific observation, communication, engineering, institutions, and exchange provide forms of foresight unavailable to ancient communities. The present is therefore neither helpless nor protected by history. It is a different climatic and social condition, carrying ancient human vulnerabilities inside a planetary system altered by modern emissions. The past teaches that civilizations rarely fail from climate alone, but it also teaches that societies become fragile when they assume familiar conditions will continue, when protection is distributed unequally, and when institutions delay change until biological and social limits are already near. Modern warming should not be mistaken for another turn of a 1500-year wheel, because doing so replaces measured causes with a convenient rhythm and turns responsibility into fate. The question facing civilization is not when the old cycle will strike, but whether knowledge can be converted into cooperation before gradual change becomes the ordinary climate inherited by generations who never knew the world before it. The deepest lesson in climate history is not that civilization is periodically erased, but that every society builds its sense of permanence inside conditions that are never truly permanent. Rivers shift, rainfall changes, coastlines move, soils weaken, oceans redistribute heat, and generations often mistake the climate of their childhood for the natural shape of the world. The proposed rhythm near 1500 years is therefore valuable only when it teaches caution, not when it is used as a countdown, because the evidence does not show a global mechanism that resets every civilization on schedule, and the last 12 centuries do not form one clean cycle beginning at a single moment. What the record does show is a repeated meeting between environmental pressure and human systems that have become too rigid, too unequal, or too dependent on one narrow set of expectations. When water, food, transport, trust, and political protection fail together, a society can lose its center. But even then, people do not return to nothing. They move, adapt, preserve fragments, rebuild locally, and carry knowledge into forms that may no longer resemble the old order. This continuity reaches back to the earliest human communities, whose survival depended not on controlling climate, but on recognizing uncertainty, sharing risk, remembering alternatives, and changing behavior before every path closed. Modern civilization has more scientific knowledge, greater productive capacity, faster communication, and stronger tools for coordination than any society before it. Yet these strengths create responsibility rather than immunity, because information matters only when institutions act on it. Technology matters only when protection reaches those most exposed, and abundance matters only when it can move toward need. The past offers no comfort in the idea that collapse is impossible, but it also offers no evidence that collapse is inevitable. It shows that outcomes are shaped by choices made long before crisis becomes visible. Maintaining varied food systems, protecting water, preserving ecological knowledge, reducing extreme inequality, strengthening public trust, and building flexible networks are not guarantees, but they widen the space in which adaptation remains possible. This is the educational value of studying ancient climate change. Not to search ruins for a date that predicts our future, but to understand how ordinary dependence becomes vulnerability, how vulnerability becomes social strain, and how strain can still become adaptation when communities preserve cooperation and alternatives. Every generation inherits both a climate and a structure of decisions made by those before it. Some decisions increase resilience quietly through maintained reservoirs, protected soils, reliable institutions, shared reserves, and knowledge passed forward, while others postpone difficulty until the cost is carried by people with fewer choices. Climate history, therefore, asks us to see civilization not as a monument standing above nature, but as a living arrangement inside it, supported each day by water, energy, food, labor, memory, and trust. The world has never promised stability, yet human beings have repeatedly survived by refusing to treat one successful arrangement as permanent. Perhaps the greatest loss is not the fall of a city or the disappearance of political authority, but the loss of the ability to imagine another way of living before the old one becomes impossible. The quiet responsibility left by this history is to notice slow change before it becomes ordinary, to measure what memory alone cannot preserve, and to listen when evidence challenges comforting patterns. Because societies are often most vulnerable when yesterday is used as proof that tomorrow will remain familiar, preparedness begins with accepting that uncertainty is real, that adaptation has limits, and that preserving human dignity during change is as important as preserving buildings, markets, borders, or the names by which an age remembers itself in later historical memory. If no hidden clock decides our fate, then what will future generations say was the moment we still had enough knowledge, time, and cooperation to choose transformation instead of waiting for change to choose for us?